Hello everyone and welcome to the Pentaho data integration tutorial focused on creating and populating a Kimball star schema. Up front, I want to set your expectations right. I assume that you already know the basics of Pentaho data integration, that you know how to create jobs and transformations, how to utilize the various steps and job entries. Just to be clear, this is not an introduction to Pentaho data integration. I also expect that you know the basics of star schemas. We will utilize various software packages throughout this course. I will not cover here how to install them, because there's really enough information available on the internet about this. So if you're not already familiar with the installation procedure, please use the online resources. Lastly, we will be using the Linux command line, so I expect you to be familiar with it. Up front, please make sure you have the following software installed before proceeding. The latest version of MySQL database server, the latest version of MySQL Workbench, MongoDB, our columnar database, Pentaho data integration version 4.4.0 stable, a SQL client of your choice like Squirrel, and please download all the accompanying files from the backed website. Then you should be ready to go ahead. In this section, we'll be looking at the structure of the raw data, so we'll speak you through the various tables that make up this schema. Once we are familiar with the raw data, we will derive a simple star schema from it. After this, we will be adding the necessary MongoDB and MySQL JDBC drivers, Pentaho data integration, so that this tool can communicate with these databases. Then we set up the raw data and the Mart databases, and finally we will define some variables which we will be using for the database connections in Pentaho Cattle. Let's get started. Once you downloaded the files, you should have a directory structure similar to this one. First off, we will create our raw database. Just a quick note, as mentioned, I expect you to be familiar with the command line. If you prefer graphical user interface, you might be able to follow as well, but really we will focus on using the command line here. So let's create our database first. So we will be using the MySQL command, specify your credentials. So in my case, it's the user root and the password root as well, which will bring us to the MySQL client. And to create the database, we just write create database and we call it SLS_raw. That's basically all we have to do. And as you can see here, it's been successfully created. Next up, we want to basically populate this database, so exit out of the client. And the way to populate it is basically use the MySQL command as well, specify database, which in our case is SLS_raw, followed by the user credentials, and then we feed in the file SLS_raw_dump.sql, which you find in the project folder as well. So just execute this, and this should populate the database. As you see, no errors, so everything went alright. So let's have a quick look again at the database. So just connect again to the client, then write use SLS_raw so that we connect to the right database, and then just do a show tables. And then we get a quick overview of the available tables. So you see there's a customer table, lens category table, a sale table, the sales channel table. To have a bit nicer overview, you can open MySQL Workbench and open the SLS_db file from the project folder. And then we can open up the EER diagram SLS_raw. So as you see here, this is a nice graphic presentation where the main table is the sales table, which tells you by date, customer ID, lens ID, sales channel, the amount that was spent. On the right hand side, you see a lens table which holds a lot of lens metadata, like focal length, aperture, and so on. And on the very right, there's a lens category table. On the left hand side, we have the sales channel table, very small table, and the customer table, which holds some customer information like name, address, city, and so forth. Let's have a look at the data itself. Let's do a select star from sales. Sale there was. So basically quite a small data set, easy to understand. So you have the customer ID here, the lens ID, which links to this lens table, a sales channel ID links over here to the sales channel table, and the amount that was spent. Then next up, let's have a look at the lens table. So select star from lens, put the limit on it, make the window bigger that we see what's going on. So basically there's some basic metadata like the lens name, aperture, minimum focusing distance, and so forth. Nothing complicated. Then next up we have lens category. So basically just telling you if it's a macro lens, normal lens, short, telephoto lens, and so on. Then one of the other tables is sales channel. So just specifying if it was a in-store or online sale. And the final table that we're gonna have a look at is the customer table. Again, as you see, very easy to understand. So we have the name, the address, city, and when this record was last updated. So basically that's all about the raw data. In the next part, we will be looking at deriving a star schema from this data. Thanks for your attention so far. Welcome to the second part of the Getting Started section. Previously, we were looking at the raw data. In this session, I will talk you through the derived star schema. This, what you see here, is the star schema I created. In the center, we have a fact table called fact sale, which contains technical keys for lens, date, and customer, all referencing the respective dimension table. What is a technical key? This key is not originating from the source data, but instead we create it either in the ETL or by using an auto-incremented key in the database. The important part is that we are in control of this key. Using a technical key insulates us from several problems that might arise if we relied instead on the source data IDs. I decided also to bring the sales channel data into this fact table because we don't have many attributes about it. Hence, it can act as a degenerate dimension here. Finally, you can see that we have one measure called sales here. Now let's talk about the dimensions. We have a table here called dim lens with a dedicated lens technical key. All the other fields you're mostly familiar with. As you can see, we have a new field in this table called lens category. Lens category in the source data has its own dedicated table, but there are not many attributes associated with it. Hence, I decided to make it part of the lens table. On the left-hand side, you see the dim customer table. Again, a dedicated technical key, and all the other attributes you are quite familiar with as well. And finally, you can see that we have a date dimension as well. In this case, the technical key is an integer representation of the actual date. I also added several common date attributes like year, month, and quarter. You have probably also noticed the foreign key relationships here on this diagram. I would advise having them enforced while in development and testing, but on production, when dealing with a huge amount of data, it is best to drop or disable the foreign keys, as data can be inserted faster this way. Keep in mind that our ETL process is the only process which inserts data into these tables, and we should take respective measures in our ETL process to ensure that the foreign key constraints are never violated. I also specified composite key to ensure that each record in the fact table is unique. In our case, each record is unique by date, lens, and customer key. Again, keep this index for development and test only, and drop or disable it in production environment. As we are here in a relational database, we have to add a few indices so that queries are executed in a reasonable amount of time. As you can see, I added a few indices as well, so that the queries run quite fast. It's quite a simple schema here. In real life, the tables might consist of many more columns, in which case we might very likely end up adding a few more indices. And usually you don't stop at defining indices just once at start, but you will have to tune them later on as well. This sounds quite like some work, right? You might wonder if there isn't any better database out there which could take care of all of this for us. And yes, that's the case. There are databases which were built to satisfy analytical and reporting workloads, namely columnar databases. With columnar databases, there's no need to define indices, which saves us time, and columnar databases are usually way faster in answering analytical and reporting queries. In our case, we'll be using the popular open source database MoneyDB. So, to sum up this section, I explained the star schema model to you, which we will be using for our data mart. Next up, we'll be looking at some configuration tasks. Welcome to the third part of the Getting Started section. Here we will be adding MySQL and MoneyDB JDBC drivers to Pentaho Kettle so that this tool can connect to these databases. We will also set up the raw data and data mart DBs. And finally, we will define some variables for the DB connections in Kettle properties. Okay, let's get started. Open up your terminal and we will start up MoneyDB with using the MoneyDB command. Start the path to your MoneyDB farm. And then once that's started up, we'll create our database, which will be called SLS, short for secondhand land store. So MoneyDB create SLS. Then we want to start it. We want to release it. And then check the status of it. All looking good. Okay, let's connect to MoneyDB using mclient. So it's mclient minus D for database, that's SLS in our case, minus U for user, MoneyDB in my case, and minus P for port, that's 54321. And that should just connect us, so MoneyDB is the password, and then we should be ready to go. And then we want to create a dedicated user, so we say create user ETL with password, single quotation marks, ETL as well. Make sure to use single quotation marks here. The schema is the sys one. Excellent. Then we will create our schema. So we say create schema called DMA, and we say authorization ETL, and then create schema agile authorization ETL. Marvelous. And then finally the use ETL schema agile DMA. Okay, wonderful. So that's all set up, so we can exit here. And next up, we will just quickly download or show you how to download Pentaho data integration. So jump over to sourcewatch.net, type in Pentaho, and then next from the list choose Pentaho Business Analytics, and then jump over to the file section. Should hopefully pop up in a minute. Okay, so you go to files, and by the time you watch this, hopefully, so click here on data integration. So by the time you watch this, hopefully there should be a version 5. So for now, I can only click on this one, but make sure you at least download version 5 and then choose the format that suits your operating system. Next, we'll download the JDBC driver from MoneyDB. So Google search, click on this page and download it from here. And then also we need the MySQL JDBC driver, which you can download from here. Okay, so I assume you have all the JDBC drivers downloaded. Also, downloaded Pentaho data integration and extracted it. And then you should have a directory like this one. Mine has a few directories missing because it's a trunk version, but don't worry about this. So navigate to your PDR root directory, and in there you should have a directory called libx jdbc. So change to this one and copy the JDBC drivers there. As said, in my case, I have a trunk version, which you shouldn't be using for production anyway. But in my case, I would have to copy it into the lib folder. But as said, for you, just change directory into the libx folder, and inside there you find the JDBC folder and put your JDBC drivers there. Okay, next up, we will set up some JNDI connections. So what's that? Basically, that's a central way of defining your database connections. So with Pentaho data integration, you have two ways of working with files, either database repository fashion or on a file-based. I usually prefer the file-based approach, so I can easily integrate with versioning tools. And JNDI connection make a lot of sense because that's the one place where you can centrally define your database connections. So here you see the first part is the name of the connection, so SLS_raw, and then you have the properties just after that. So you define the type, the driver, the connection string, username and password. So all we do is you find this file actually within the files you downloaded from the paved website within the config PDI folder. So you can just easily copy that over, and here in the PDI root folder, just type in vi simple JNDI and JDBC properties, jump right to the end, then insert and copy that over and save that. Next up, give all the necessary rights to shell files, and then we can start spawn the graphical user interface. And then we will very quickly define in here the database connections. So just create the transformation, and in here on the view tab, right click on database connections, say new, and then first we'll create the one for the raw data. So choose MySQL here, JNDI, just type in their name, so SLS raw, check test, working fine. Okay, expand here, right click on it and say share. This way, any new transformation or job that you create can access this connection. And then next up, we will define the one for the data mart DMA, MoneyDB in this case, and SRI DMA. Test again, all fine, click OK, and that's it. So we don't need to save that for now. Sorry, we need to share this. Okay. Basically, we have set up everything that we need to start creating our ETL transformations. So stay tuned. The next session is going to be really exciting. Thanks for now. Welcome to the first Agile chapter. Why do I want to expose you to this approach, you might ask? It's a quick way of understanding the structure and quality of the raw data. We want to see if there are any quality problems with the raw data and fix them in a very quick fashion. And also, we want to see what dimensions and measures there possibly are, play around with them, create a prototype that we could possibly already show to the client and get some initial feedback from them. To sum up, the Agile approach offers a quick way of understanding the raw data and creating a prototype. It is ideal to go through this process before creating a full-blown ETL solution to populate data mart. In this part, we will import the joint original data set, provide useful column names, and output the data to MoneyDB using the standard table output step or the bulk loader step. Open your favorite query client. From the files that you downloaded from the paved website, you can find a folder called scripts, and inside a file called agile-input-query.sql. Double click on it to open it. This is the input script which we want to use for our ETL process. I will explain the script briefly. We join all the raw data tables together so that we get a combined data set. You can also see that I mention all the fields here properly. This is to keep the data set as slim as possible. Another thing that you probably already realized is that I renamed some of these fields. Some fields are quite generically named, like date, name, and so forth. So we want to provide a more descriptive name to those fields. Further down the query, you can see that I use a left join. The reason for this is that we want to import all the data from this main fact sales table and not only the rows where the join condition is satisfied. There might be problems in the raw data that we are not yet aware of, so by using a left join, we can source all the data from the fact table. So let's execute the query to see that it's working and it's looking good. Let's copy this query and then move over to Spoon, create the new transformation and save it then in a dedicated project folder. Name it tr_fact_sale_agile. Click OK. From the input folder, add the table input step, double click on it and replace the default query with our query. Then set the connection to SLS raw and let's do a preview now to make sure that everything is still working. It's looking marvelous. So basically the first part is done. Stay tuned, the next part is gonna get even more exciting. Welcome to the second part of the Agile section. In the first part we had a look at how to source the raw data. In this part we want to output the data to our columnar database, which in our case is MoneyDB. There are two ways to output the data to MoneyDB. Inside the output folder, you find the table output step, which is the standard way of outputting the data to a relational database. Just drag and drop this one onto the canvas. Columnar databases are quite bad in inserting data on a row-by-row basis. This is why usually each columnar database has a bulk loader step, which you can find here on the left-hand side in the bulk loading folder. There is a dedicated one for MoneyDB. We'll have a look at this one in the last part of this section, because beforehand I just want to output the data using the standard table output step. Why am I doing this, you might ask? Currently I feel it is easier to analyze potential errors with the table output step than it is with the bulk loader step. This might well change in future, but right now I recommend using the table output step to make sure that the data gets inserted properly and only then switch to the bulk loading step. So now create the hop between the table input and the table output step. How do you do this? You press down the shift key and drag and drop the mouse pointer from the source to the target step. I expect that you already know this, but I repeat it here again. Next, double click on the table output step and choose one of the connections we set up earlier on, namely SLS_DMA. Then click on the browse button next to target schema so that we can choose the appropriate schema, which is agile in our case. For the target table, type fact_sale. This table doesn't exist yet. We will use the auto-generate function in a bit to create it. Next, tick truncate table. The reason why we do this is because we run the same transformation several times with the same data set. We want to clear out the target table each time. This is for testing and prototyping purposes only. The only other setting that we want to change here is untick use batch updates for inserts. The reason for this is that in this case we will get return proper error messages from the database. Next, hit the SQL button. You will see that we have here a very nice create table statement. Right now, I'm not too much concerned that the column types and specifications are 100% correct. Probably sometimes we could use an integer instead of big int and so forth. I don't worry too much right now about this because we only use a very small data set and it's for testing only, and we will not use this table later on again. So right now I just click execute and we see it's been executed successfully. So let's close this, click OK. Let's execute this transformation, hit the run button and then launch, and we will see that 16 records get outputted to the target table. That's what we expect. So let's just quickly run select star from agile.factSale in your favorite query client. Let's put the limit on that, 10. And you see the data got inserted quite nicely. So just one word on spotting the errors. So within the logging tab in here, you might see some red error messages showing up. Usually you have a mismatch in the type of a specific field or a column is misspelled. So we always have to take care that the column names and the types match, and once you can insert the data successfully with the table output step, it's about time to switch to the bulk loader step, which we will have a look at in the next part. Until then, stay tuned, it's only gonna get more exciting. Welcome to the third part of the Agile chapter. In the previous part, we had a look at how to output the data to MongoDB using the standard table output step. We verified that everything was working, that there was no mismatch between the data types in Pentaho, cattle and MongoDB. So everything is running perfectly. Now we are in the position to start using the bulk loading step. On the left hand side in the bulk loading folder, you find the MongoDB bulk loader step. Just drag and drop it onto the canvas. Disable the old tab and create the new one, and then double click on the MongoDB bulk loader step. You can see that the configuration settings are fairly similar to the table output step. We can choose a connection here as well, in our case SLS_DMA. And then we also need the schema name, table name, buffer size, and the log file name and so forth. We will not fill this out right now. We think a bit ahead and can imagine that we'll be using this step in several other transformations, so we don't want to hardcode these settings here. It would be rather annoying if we had to change all the individual transformations in future in case the configuration details change. So we will use parameters instead. So just click OK here. There are two ways to configure parameters. One is by clicking on edit the cattle properties file, and then just add your new parameters at the very end. You can see that I already defined here by MongoDB bulk loader buffer size, log file, the M client location, the schema and the table name. So here, you see here on the right hand side, I already specified the values. So set this up on your side. Make sure that especially the M client location is correct. It might be different on your system, so double check this. And once you define the parameters, click OK. Alternatively, you can define the parameters directly in the cattle properties file, which resides inside the hidden folder called cattle inside your home directory. You can just open this with a normal text editor and add your new parameters at the end. In both cases, you have to restart Spoon so that the changes can take effect. So once you've done that, let's go back, double click on the bulk loader step, and then I will show you a very handy shortcut. So put your mouse cursor into the input field for target schema and then press Ctrl space. I repeat again, Ctrl space. You will see a list of all available parameters. As we know that our parameter starts with a V, we just press V and then we can scroll down and pick the respective one. So in our case, it's gonna be schema. Then you repeat the same process for all the other ones. Table, next the M client, buffer size, and the log file. Then for the encoding, choose UTF-8, tick truncate table, and then click on Get Fields. The mapping should all be properly done. Just check it quickly and then click OK. Next up, let's run this transformation and make sure that everything is working as expected. So you see that 16 records get outputted to the table, so everything is working as expected. So let's sum up what we did in these sections. We were importing the raw data by joining all the input tables together. Then we were outputting the data first using the standard table output step. Once this was working successfully, we replaced it by the bulk loading step, which, please remember, is the way more efficient method of loading the data into a columnar database. Just remember this and you'll be fine. So here we go. Stay tuned and I'll see you in the next section. Welcome to the second Agile section. This time we'll have a look at how to create an analysis model, which is really another name for an OLAP schema. Then we will use Pentaho Analyzer to further understand our data. Are there any specific problems that should be fixed? Once we find the problem, we can go back to our transformation and adjust it. We then analyze the data again in Pentaho Analyzer and see if it is really fixed now. If it is not entirely fixed or if we find a new problem, we go back again and improve the transformation. Go through this iterative process as long as it takes to output good quality data. Again, this is for prototyping only. Once we have all the learnings, we can start with a full-scale implementation of the ETL process. So let's get started. Remember that we created this transformation before. We'll just disable the hop to the bulk loader step and enable the one to the table output step. The reason for this is that the model and visualize perspective only work with the table output step. So right click on this one and choose model, which will bring us straight into the model perspective. Here you can create your OLAP schema. Pentaho also offers a dedicated tool to create OLAP schemas, which is called Schema Workbench, which you might use to create more complex schemas. Normally, you would spend some time to create a proper model here, but for the sake of this tutorial, I will just create a simple version. After watching this session, I recommend that you create a complete model and analyze data further. Okay, let's add sales to the measures, and then let's sale date, sales channel, lens name, and customer name to the dimensions. That should be enough for a very quick analysis. Note that you also have an auto-populate function up here, which would take a good guess as to whether a data point is a measure or a dimension. Personally, I find it quicker to just assign the fields manually to the dimensions and measures in most cases. We also have to configure the reporting model, so click on the reporting tab. Basically, the reporting model is the metadata layer, which you can also create in Pentaho metadata editor. We will not make use of the metadata layer here, so just add any field to the categories to omit any error messages further down the line. Switch back to the analysis tab, click the save button and save it in our dedicated project folder as sls.xmi. And now we want to switch to the visualize perspective, and we can do this by just clicking here on the go button. So this should load up in a minute. Let's quickly sum up what we have been doing so far. To create your analysis model, right click on the table output step and choose model. Once you build your model, you can switch to the visualize perspective to analyze your data. So that's it for now. I shall see you in a bit. Welcome to the second part. Now it will get quite exciting. We will analyze our data with Pentaho Analyzer, part of the Agile plugin for Pentaho Kettle. Normally, Pentaho Analyzer is only available in the Pentaho BA server, the Enterprise edition, but here we can use it as part of the Kettle Agile plugin. So let's get started with analyzing our data. Just drag and drop the measures and dimensions into the layout panel, and the main window will display pivot style reborn. So let's add sales, measures, lens name to rows, and to make it a bit more interesting, we'll add the sales channel to columns. Let's make some space here that we can see the data. So if you look at this, you can see that we have two similar values for store, one being in store and the other one being store. So clearly they should be the same. So really we have to rectify this problem. And the good thing is that we can just go back to our data integration perspective and implement a fix for this. So click on the button for data integration. What we will do right now is from the transformation folder, we will insert the value mapper step onto the existing hop. So make sure that it's properly placed on it. You see that the hop gets a bit pulled, and then it will ask if it should split the hop, which we confirm. Double click on the value mapper. For the field name, choose sales channel. For source value, type in store, and we want to map this to store. Click OK. Save your transformation. Let's run the transformation again. Click on the Run button and then click Launch. Once it is executed, make sure that it's executed successfully, so you see that the values got outputted and there's no error anywhere. Then we can go straight back to the Visualize perspective. So just click up here, top right hand corner on the Visualize button, and then next thing we want to do is basically refresh the model. So click here on Refresh the data so that the cache is cleared, and you will see that the data gets instantly updated with the latest data from our table. So you can clearly spot here that our problem is fixed. We have just one value left for store, and it's looking way better now. You must have realized by now what an efficient workflow this Agile plugin allows. A change in the data integration perspective gets instantly reflected in the Visualize perspective. You go through this iterative workflow until you reach a point when you have good quality data. I think this is really one of the standout features of Pentaho data integration. So let's sum up. In this part, you learned how to analyze the data in an easy fashion using the Pentaho Analyzer, which allowed you to spot problems in the data. Then you provided a fix to your transformation and tested the result again to see if the problems were rectified. Remember, you go through this cycle until you reach a point where your data is clean and of good quality. So that's it for now. I shall see you in a bit. Welcome to the last part of the Agile section. This time I will show you a different tool to analyze your data called Data Cleaner. Okay, let's get started. To install this tool in Pentaho Cattle version 5 or later, go to Help and choose Marketplace. From there, you can conveniently install Data Cleaner. For Cattle version 4.4, which I'm using here, you can download it from this page. Just Google for Pentaho Data Cleaner plugin and it should be among the top 10 hits. Here you also have install instructions, so I won't go through this here in detail. I've already installed the plugin, so I will skip this process. You can use the Data Cleaner on any step, which is really good. In our case, we want to analyze the data on the value mapper in example. Right-click on this step and choose Profile, which will bring up the Data Cleaner interface. Once launched, Data Cleaner provides various analysis options by default on your data points. You can just click the Execute button in the top right-hand corner, and the report with detailed statistics will be created automatically for you. There's a huge amount of information available, like row count, what is the highest value, lowest value, sum, mean, and so forth. Also interesting statistics on string values. So all in all, a very useful tool. And remember, you can use it on any step of your transformation. This here is just a sample report. There are a lot of other options available in this tool. Unfortunately, we do not have the time to go through this right now. Just keep in mind that Data Cleaner is another very useful tool to analyze your data. So let's exit out of here, back to Pentaho Kettle. What I usually like to do as well is to check if our input data set has unique rows. So let's add the sort row step to our transformation. We will add it as the second last step. Double click on it and tick only pass unique rows. And for the fields, define lens name, sales channel, sale date, and customer name. And then just click OK. Save this, and now let's run the transformation again. Hit the run button, then launch. Now we want to pay special attention on the step metrics. We can see that the table input shows 16 rows that were inputted, whereas the table output step only shows 15 rows that were outputted. So clearly we had one duplicate in it. This is quite concerning, so you should go back to your client and discuss what to do about this. If it is a real duplicate, you might just discard it, or even better, put it in a dedicated error table. Or your client might even reveal some other news that is quite important, and you might have to change your data handling respectively. So it is always best practice to go back to your client and talk about this. So that was it on the whole agile topic. I think you could see the huge benefit of using this approach, mainly getting an understanding of the quality of the data, fixing any data quality problems, finding out what are the dimensions and measures, and you can already very quickly demonstrate a working prototype to your client and see if the multidimensional model fits the client's expectation. And very importantly, get loads of feedback. The next step is then to create a full-blown ETL process, which we will have a look at in the next few sections. That's it for now. I shall see you in a bit. Welcome to the Implementing the ETL Solution chapter. In the next few chapters, we will create transformations to populate the dimensions in parallel. Later on, we will create a transformation to populate the fact table. Please note that populating the dimensions first via dedicated transformations and only then populating the fact table via another dedicated transformation is the standard setup. But if you have a very simple setup, let's say 1 or 2 fact tables and no conformed dimensions, you could theoretically create one transformation which updates the dimensions and the fact table in one go. In this chapter, you will learn how to populate the slowly changing dimension of type 1 and 2 with Pentaho data integration. In the case of a slowly changing dimension of type 1, we do not preserve any history. So we will apply this method on the lens data, because we assume that if something changes, it will be just a correction of the data. For slowly changing dimensions of type 2, we will be using the customer data, where we want to preserve the history. In an example, we want to see what the previous address of a specific customer was. Okay, let's get started. In Spoon, create a new transformation and save it in our dedicated project folder as dim lens. Then we will create our input query, so switch to your favorite query client. Here I've already prepared the query. I will briefly speak you through it. So, as mentioned earlier, don't just write select star, but mention the columns explicitly. In case they are quite generically named fields, rename them to something more meaningful, like here rename name to lens name. You can see here further down the line that I use the left join to join onto lens category, for the reason that I want to return all the rows from the main lens table. Okay, let's make sure this query is working and execute it. As you can see, we get the nice result set returned. Next, we have a look at the DDL, so the create table statement. Here you can see that we use the dedicated DMA schema, a prefixed the dimensional table with dim underscore so that it's easier to identify, and I suffixed it with underscore simple for the plain reason that we will explore two methods of updating a slowly changing dimension of type 1. So this is for the exercise only. In real life examples you would just have one dedicated dim underscore length table. As with every dimensional table, you have a technical key here, it's length underscore dk, that's a primary key and it's auto incremented. Then for all the other fields, you can see that this time I spent more time on finding the proper column types. So here we really want to make sure that we find a suitable column type. So let's execute this query to create our table, and then we can switch back to our input query and copy it and switch back to Spoon. Here from the input folder, choose the table input step and drag and drop it onto the canvas. Double click on it and replace the default query by our query. For the connection, then choose SLS underscore raw. Here we want to make sure again that the query still works, so click preview and it's looking good again. Click close, then OK, and save the transformation. The next thing we have to do is change the parameter value of the schema parameter we set up earlier on. So go to edit and then click edit the kettle properties file. Then search for var monidb bytecloser schema and replace agile by DMA. Click OK. Now we have to restart Spoon so that this new parameter value is read in. And then once Spoon is available again, we will add an insert update step to output the data. The logic behind this step is that we insert any new data and update any existing one. So now go to design, open up the output folder and drag and drop insert update onto the canvas. Create the hop between these two steps and then double click on insert update. From the connection, choose SLS DMA, so in this case we want to output the data to monidb. For the target schema, press Ctrl space and then scroll down to find our var monidb bytecloser schema parameter. Our target table is called dim underscore length underscore simple, and then the next thing we have to do is to specify the keys. So in this case it's length ID equals length ID. Then just click on get update fields, and the only thing to change here is set length ID, the update attribute, to no. Then click OK. Okay, let's test our transformation now. So hit the run button and then launch. And you can see that records are outputted properly to our dimensional table. Please keep in mind that you should use a version control tool for any file that you create. There are popular open source tools like Git or SVN available in example. Also use a database change management tool like Sketch, NextStep or dbmaintain to deploy your database changes in a proper fashion. Unfortunately, we do not have time to cover this in more detail here. So, just to recap, what did you learn in this session? We created a transformation which sources the length row data and inserts the data into the dimension using the insert update step. This is a slowly changing dimension of type 1 which doesn't preserve any history. So that's it for now. I shall see you in a bit. Welcome to the second part of the slowly changing dimensions chapter. Previously, we had to look at how to populate a slowly changing dimension type 1 with the insert update step. In this session, we will try to create a future-proof version of the previous transformation. Sometimes you don't know beforehand if you need the slowly changing dimension type 1 or type 2. So you might in example start off with a slowly changing dimension of type 1, but after some weeks you realize that you will actually need to preserve the history and hence use a slowly changing dimension type 2. Sometimes it is also your client which goes through a similar experience and tells you at some point to preserve the history for a certain dimension. There is a way to set up the lens dimension so that it is flexible enough to cover slowly changing dimension type 1 and 2, and in this session I'll show you how to do this. So let's get started. Open your favorite query client where we will create the DDL for this table. As you see, I've already prepared it. The create table statement is fairly similar to the previous one, just that in this case we have 3 additional system columns: version, date from, and date to. Date from and date to specify the period for which a particular version of the history is valid. Now let's execute this statement to create the table, and then switch back to Spoon. We will now use a step from the data warehouse folder called dimension, lookup, and update. Just drag and drop it onto the canvas and create the hop from the table input step to the dimension, lookup, update step. You would be asked if you want to copy or distribute the records, so choose copy here. Normally, you would only have one output step, but in this case, I wanted to expose you to both the insert, update, and the dimension lookup update steps. So hence, for this exercise only, we have 2 output steps. Double click on the dimension lookup update step. Basically, this step allows you to maintain slowly changing dimensions of any type. For the connection, set SLS_DMA. For the target schema, we will use again the parameter we set up earlier on, which is var monidb bar-includer schema. The target table is called dim_lens, and then we have to specify the keys, which in our case would be lens ID, the dimension, and lens ID in the stream. Our technical key is called lens_dk, and the creation of the technical key should be based on the table maximum +1. We can leave all the other settings as is, so we will be using a version field, date from, date to. In this case, we will not use a date field because we only want to maintain a slowly changing dimension of type 1. Next, click on field and then on get field, and now we have to define the type of dimension update. So for all of them, we just want to update them, which is called punch through here. So always use the context menu here, which gives you some additional information about the type. So we will set punch through for all of the fields. So that's a bit of work here. Just double check again if all the fields are set to punch through. That's looking good. And then click OK. So that's all the configuration that you have to do. Save your transformation. And now we want to test it. So press the run button, then launch, and let's see what's happening. So you see that records are outputted here. So everything is working as expected. So remember, I told you earlier on that this setup is future-proof. So should you at some point decide to change the type of the dimension, you can just come here and set, for example, the type of dimension to insert for a slowly changing dimension of type 2. So this setup is way more flexible than the previous one, and I recommend that you use this in cases where you're not quite sure the dimension is gonna be of type 1 or type 2. That was it for now. I shall see you in a bit. Welcome, ladies and gentlemen, to the third part of the slowly changing dimensions section. Previously, we had been looking at populating a slowly changing dimension of type 1, where we didn't want to preserve the history. Now, with our customer data, we want to preserve the history, so we'll be looking at creating a transformation to populate a slowly changing dimension of type 2. So first things first, we will create the input statement, looks like this. So just mention all the fields that you want to import, rename any generically named fields like name in this case. So we rename it customer name, and then very important, order by the last updated field. So a date field which basically preserves the historic order of the data set. Okay, let's copy these records, switch over to Spoon, create a new transformation, save it, name it dim customer. Then we will choose from the input folder the table input step, double click on it, copy and paste the query in there. For the connection, choose SLS raw, click on preview to make sure everything is still working. You see here everything is properly sorted by the date field, so that's okay. Click on OK. Next, from the data warehouse folder, choose dimension lookup update, connect these two steps, double click on the last one, connection set SLS DMA. For the schema, make sure you reuse the parameter we set up early on. Dimensional table is called dim customer. We want to enable the cache to have a fast lookup, plus in our case the data set is quite small, so it fit in the memory. Our key is the customer ID, and then the technical key we call customer TK. Version fields we leave it as it is, and very important here, the stream date field, that's the one you want to pay special attention to. So in our input data set, last updated is the field that basically tells us when a record was changed. So we want to mention this one here. Can leave everything else here the same. Then click on the fields tab, hit get fields, and move the last field, last updated. And you make sure everything is on insert here, which basically, as you can see by the context help text, is for Kimball type 2 updates. So that's basically it. Now we want to create the DDR, so you hit the SQL button. You can amend this slightly, so my version looks a little bit different. I've prepared that already. So this create statement I will run, and then after this, click OK here and just execute the transformation, and let's see what's happening. So we see 11 records got inserted. That's what we expect. So obviously we want to test if the update strategy works. For that purpose, I prepared in the SLS raw data generator folder another spreadsheet ending in SCD, which basically has two records changed, which are highlighted here in red, and also a new one, which is highlighted in green. So we have to load this data, and you can do this by opening your terminal, navigating to the folder where you saved all the project files, and then just execute MySQL SLS_raw, and then basically mention your user credentials and feed in the SLS raw SCD dump SQL file. Now let's execute the transformations again, and after this we will see what happened to the data. So again, the lens one as well, and as we saw, the customer one is already finished. So let's have a look. So let's run a select on the customer table, and here you will see we have now new versions here. It's not just one but two as well. And you see for Mr. Diego Sanchez and Mrs. Radcliffe, we have new records here as expected, and watch out for the date from date here. So we see with both records, the record changed on the 20th of March. So that's quite important. And then with the lens data, you can have a look yourself, but basically you will see that they are still only version 1. Actually, let's run it quickly as it finished. So you see everything is still on version 1, and the reason for that is because we said, okay, don't preserve the history, just update the records. So, summing up, you learned how to populate the slowly changing dimension type 1 and 2. Next up, you will learn how to populate the fact dimensions. So, see you soon. Welcome to the Populating the Date Dimensions section. Here we will be having a look at an ETL transformation which pre-populates the date dimension up front. Why are we doing this up front? The reason is that we already know beforehand which date range our fact tables will cover roughly. So there's no real need to run this transformation every day. We want to be able to supply a start and end date to our transformation. The transformation figures out how many days there are between the start and end date and then creates for all these days the required date attributes and outputs the record to our dedicated MoneyDB table. Let's have a look at the create table statement in our favorite query client. Our first column is the date technical key, which is an integer representation of the date. This is a kind of fake technical key, which is very useful because we don't have to look up the value, can always derive it from the raw data. And also it can be used for table partitioning as well. You can see that we have various other date attributes as well, like normal date, year, quarter, month, week, and so forth. Let's execute this query to create this table. Switch back to Spoon and create the new transformation. Save it in our dedicated project folder as tr_dim_date. Next, we want to specify the parameter, so right-click onto the canvas, transformation settings, and then click on the parameters tab. Our first parameter is called var_start_date. Set the value to the beginning of 2013. The next parameter is called var_n_date and set its value to the beginning of 2014. Now click OK and save the transformation. First, we want to add a generate row step. Double click on it, set the limit to 1 and click OK. Next, open up the job folder and select Get Variables. Add it to the canvas and connect it to the previous step. Double click on Get Variables and we will define following field, start date, set the variable to $opening curly bracket var_start_date, closing curly bracket, set the type to date and the format to this one here. So we will be doing exactly the same for the end date. Again, the type is date and the format we set again to this one. Now click OK. Let's save it and do a preview on the last step to make sure everything is working as expected. And it's looking good. We successfully retrieved the start and the end date. What we want to do next is to calculate the amount of days between the start and end date. So open up the transform folder and choose the calculator step, add it to the canvas and connect it to the main stream. Double click on it and define a new field called days. For calculation, just search for date and then we want to choose date A minus date B in days. Click OK. For field A, specify end date. For field B, specify start date. Set the value type to integer. Then click OK. Let's do a preview again on this step. Make sure everything is working. So we will get returned 365 days, which is what we expect. What we want to do next is to create as many rows as there are days. So we can just search for the clone row step and add it here at the end of our stream. Connect it again and then double click on it. So we want to specify that the number of clones is coming from a field, in our case days, and then we want to add the clone number to a special field which we call clone number. There will be one row more than we need, but we don't worry about this right now. So click OK and then let's do a preview to see the result, which is quite interesting. We see that we now have many entries. Everything is working as expected. You also see here on the right hand side we also have this clone number field. Click close. So now we are finished with the first session. We have achieved what we wanted, namely cloning the rows as many times as there are days. In the next session we will have a look at using the calculator step to derive all the required date attributes. That's it for now. I'll see you in a bit. Welcome to the second part of the Creating the Date Dimension chapter. Previously, we created a transformation which accepts the start and end date as input parameters and creates as many rows as there are days between these two dates. Now, we want to derive all the basic date attributes like year, quarter, month, week, and so forth. We will use the calculator step therefore. Add the calculator step to the very end and connect it to the stream. Double click on it, and the first thing we have to do is to create the proper date for each row. So create a new field called the_date, and for the calculation search for date, and then we want date A plus B days. For field A specify start date, for field B specify clone number. Set the value type to date, and then we also want to specify the mask, which is this one here. So let's click OK, save, and then do a preview on this step to see if everything is working properly. And as you see here, our date is properly incremented every day, so everything is working as we expected. Click Close. Next, we want to specify the various date attributes. So let's create a new field called the_year. For calculation, search for year to slim down a bit the list of possible calculations. Then choose year of date A and set field A to the date. The value type should be integer. Next up, create a field called the_quarter. Search for quarter. And then choose quarter of date A, should be based on the year, and the value type is integer. Next, field the_month, search again for month, and then the calculation should be month of date A, and field A is the date. Value type again integer. Finally, the week, search for week here. So we want week of year of date A. Field A set to the date, and the value type again integer. Next up, some day attributes. So first one being day of year. Search for year, and then we choose day of year of date A. Set field A to the date, and value type integer. So it's a bit of work, but it's not really anything too challenging. Next, day of month. Search for month. So we want day of month of date A based on the date and value type integer again. Finally, day of week. Search for week. Day of week of date A is our calculation type, and then that should be based again on the date, and it's an integer. So we have derived now in an easy fashion all the possible date attributes. Just click on OK, save this, and we want to check if this is working. So right click on the calculator step and let's do a preview on it. Okay, let's see. So we have, for example, the 1st of January 2013. It's the first quarter, first month, first week, and so forth. Looking good. So let's scroll down a bit to make sure everything is changing respectively. It's all looking very good. So we're happy with the result, and now we can click Close, and we have accomplished the main task of this session, namely deriving all the required date attributes. So to sum up, the calculator step offers a very easy way to derive all kinds of date attributes. So far, that's it for now. I shall see you in a bit when we finish this transformation. Welcome to the last part of the Populating the Date Dimension chapter. Previously, we started work on a transformation which creates all the required date attributes. Now, what is left to do is to create the date technical key and to output the data. In order to create the technical key, we will use the user-defined Java expression step from the scripting folder. So drag and drop this step onto the canvas and connect it to the main stream. Double click on the user-defined Java expression step and create a new field called date_tk. For the Java expression, I will use this snippet here. So basically, this takes our input date, formats it into a string using this format here, and then converts it to an integer. So the value type that you want to set here is integer. Click OK. And now let's do a preview and see what's happening. Let's study the results properly. So on the very right hand side, we find now our date decay. And you see it's a proper integer representation of our initial date here. So everything is working as we expected. Next up, we want to slim down the data set. So from the transform folder, select the select value step and add it to the stream. Double click on it and click get fields to select. And now we will get rid of the fields that we don't need anymore. So we don't need the start date, the end date, the dates, the clone number. All we want to keep is the date decay, the date, year, quarter, month, week, and the various days. So that's it. So click OK. Let's do a preview again, just to make sure that we're happy. It's looking much better now. So very last step that we're up to is outputting the data to MongoDB. Since the data set is not really that huge, we will just quickly use the table output step. Double click on it. For the connection, define sls_dma. For the target schema, press again Ctrl space and jump down to our parameter that we set up earlier on. So this var MongoDB bulk loader schema. Target table is dim_date. Next, tick truncate table. The reason for this is that in one go, we create the whole required data set with this transformation and output it to the target table. So next time we run this transformation, we want to make sure that we wipe out the contents of the table first before inserting data set again. Then you want to disable batch updates. The reason is that on the very first run, we want to see meaningful error messages in case there's a problem. After the first run, you can enable it again. Then tick specify database fields. Click on the database fields tab. Next, click enter field mapping. And here you see the source fields, which are coming from our transformation, and the target fields, which are the table columns. So click the guest button and then double check if the mapping worked out properly. So that's looking good in our case. Click OK, and then you will see the mapping showing up in here in this tab. Sometimes you might encounter problems here that when you click enter field mapping, that you get some weird error message. Always check first if the table name is correct. If that's not the problem, then go over here to view, right click on database connections and choose clear complete DB cache. Then go back again and click on enter field mapping. This should have basically solved your problems in most cases. Click OK now. So let's run this transformation. Click on the run button and then launch, and let's see what's happening. And surprise, we got an error. I want to show you now how to fix this. This is quite important here in PDI version 4.4. There is a bug, and I will quickly show you how to figure this out. Let's have a look at the log. Scroll a bit further up to see the error message, a proper one. So here we have wrong type for argument 2 of prepared statement, timestamp, expected date. So double click here again, and our second field is the date, which is in proper date formats. Just double check this. Here, show output fields, and we have it on date. So we need the workaround. That's a bug which will be hopefully fixed in one of the next versions of PDI. And the workaround is to use the select value step from the transform folder, add it here, double click on it, then go to the metadata tab and choose the date again, set the type to date, and then, that's very important, set precision to 1 and format to this one here. So here month date with the dashes, click OK, and now when we run the transformation again, everything will be inserted just fine. So let's just double check this, where you will see here our date got inserted properly. So that's it for now. We went through a cool example on how to pre-populate a date dimension. I think that's been quite interesting, and it demonstrated how easily you can actually create such a transformation in Pentaho Kettle without actually using much coding. So that's it for now. I shall see you in a bit. Welcome to the Creating the Fact Transformation chapter. This chapter covers importing the source fact data, looking up the technical keys for slowly changing dimensions of type 1 and 2. For the date, we will create a special technical key, and finally we will output the data to MoneyDB. So let's get started. First off, open your favorite query client. Here we will prepare the create table statement for the fact table. I will briefly speak you through the create table statement. Our table is called fact_sale and resides in our dedicated schema. Please note the prefix fact underscore for the table name, which helps to easier identify the fact table. In regards to the columns, first we have the date technical key followed by the sale ID. We keep the sale ID so that we can properly trace the record back to the source system. Sometimes you will have to do some cross-checking, so having the sale ID here is essential. The next column is sales channel. This is a degenerate dimension for the reason that there is only one attribute associated with it, so it is not worth creating a fully blown separate dimension for it. Next, the length technical key and the customer technical key, and finally we store the measure, which is sales. So let's execute this query to create the table. They all worked fine. Next up, we have to create the import statement. This is a simple select statement. Again, list the columns that you really need to keep dataset slim. Also rename any generically named fields like the date to sale date and the amount to sales. Again, we use the left join to join onto the sales channel table in order to return all the rows from the main table. Let's execute this query to see if it's working. That's looking fine. So just copy it, and now let's switch back to Spoon. Next, open up the agile transformation we created earlier on and save it in our dedicated project folder as tr_fact_sale. Then remove the two output steps, double click on the table input and replace the input query with now our new input query. Do a preview to make sure that the query is still working properly, which it is in our case, and save the transformation for now. Now let's double check if the other steps are still set up correctly. So we still have the sales channel field. That should be working fine. Double click on the sort rows step. Replace customer name, customer ID. Lens name with lens ID. And the two other ones should be still fine. Click OK. Save. Do a preview to make sure that everything is working properly. That's looking good. Click close. So to sum up, this was a very quick introduction on how to import the fact row data. In the next session, you will learn how to retrieve the technical keys. So stay tuned. I shall see you soon. Welcome to the second part of the Creating the Fact Transformation chapter. Previously, we created this transformation which sources the raw data. It's now about time that we perform some checks on the data. We will only cover one example here. In reality, we will perform many more checks. So click on Design and from the Flow folder, choose the Filter Rows step and drag and drop it onto the canvas. Connect it to the main stream. Double-click on the step. We want to check if the sale date field has a value. So choose the sale date field here. And then for the condition specify is not null. Click OK. Add a dummy step and direct the error flow to it. So choose result is false. In a real project, you certainly shouldn't do that. Instead, use a table output step and save this record to a database so that you can later on analyze it. Right now, unfortunately, we don't have enough time to do this, so I take this shortcut just for this exercise. Next, we want to look up the technical key for our lenses. How do we do this? From the lookup folder, choose the database lookup step and add it to the canvas. Connect this step to the main flow. Choose result is true. So remember, we only want to pass on records to this step which have a date value. Next, double click on the step. Give it a bit more descriptive name. So we say lookup lens decay. For the connection, choose SLS_DMA. The lookup schema can make use of setup earlier on. So let's say var_db DMA schema. The lookup table name is dim_lens_simple. Remember, this is a slowly changing dimension of type 1 where we don't preserve any history and we will only be using the database value lookup step with this type of dimension. Next, tick enable cache because we want to have very fast lookups. And as we know, dataset is quite small. We also load all data from tape. Now we have to define the keys. So in our case, that is lens ID. First, lens ID. So these are the lookup keys. And the values that we want to return is just the lens decay. The type is integer. And we want to assign a default value of 0 in case the lookup doesn't return any value. I choose 0 for the reason that usually the auto-incremented key on the database side starts with 1. So 0 then clearly indicates that lookup didn't work. Click OK. And now let's test this transformation. Let's do a preview here. See what's happening. It's looking good. So you see that the lens decay is retrieved here properly. So our first mission is accomplished. To sum up, we import the raw data, do some basic quality checking, and then we implemented a process to look up the technical key for the lens. So that's it for now. I shall see you in a bit when we will look up the technical key for the customer dimension, which is a slowly changing dimension of type 2. Welcome, ladies and gentlemen, to the third part of the Creating the Fact Transformation section. In this part, we'll be having a look at retrieving the technical key for a slowly changing dimension of type 2. So drag and drop the dimension lookup update step onto the canvas and connect it with the main flow. Just double click on it Next, we want to look up the customer technical key, so that's a slowly changing dimension of type 2. From the data warehouse folder, choose the dimension lookup update step, connect it, double click on it, and now very important, make sure that you untick update dimension, because here we just want to basically look up keys, not update any records. Connection is SLSDMA. For the schema, remember to use the parameters we set up earlier on. The table name is theme customer. We can enable the cache, results in a faster lookup. And keys customer ID. And the technical key is customer DK. And then, very important, the stream date field set to sale date, so that they can look up the correct historical version. Everything else, leave set exactly the same, so no fields here on this step, everything else the same. So let's click OK here and do a preview. Remember, that's actually quite a complicated process going on here. Basically, Kettle has to find the correct historical version of a customer record. So you see on the right hand side, everything is working properly. And by using this dedicated Kettle step, actually the setup for us is extremely easy, and all the complicated processing is happening in the background. Next up, let's create the date technical key, and you guessed it, we're gonna use the user-defined Java expression therefore. So let's add this to the main stream, create a new field called date decay, and you're familiar with the Java expression, so we just format the date to a string and then convert it to an integer, and the output type here is of course integer, so give this a nice name as well, date decay. And let's do a quick preview on it to make sure that it's working. Looks good. Here on the right hand side you see a nice integer representation of the date. And then next up we want to slim down the main stream, so we use a select value step, get all the fields and get rid of a few fields that we don't need, say the customer ID, lens ID, and then use control and the arrows to get the fields into the right position. So that looks about right, should be the same as in the table definition, so that we don't have to worry about this anymore. Okay, and then finally we want to output the data to MoneyDB. So as said, for testing, let's use the table output step. Then connection, we use SLSDMA. For the schema, again we reuse the parameter. The target table is fact sale, and we want to disable use batch update for inserts for testing, because we want to see a proper error message. Then hit OK, and let's run this transformation quickly. And you see everything is working smoothly, so that's good. Let's disable that hop and add the bulk loader. Drag and drop it onto the canvas. Then connect it to the main stream. Double click on the MoneyDB bulk loader step now. Set SLS_DMA as the database connection. Press Ctrl+C in the target schema field and look for the parameter we set up early on. So we want MoneyDB bulk loader schema. The target table is called fact_sale. Specify the mClient path, again reference the parameter. So in this case we want MoneyDB bulk loader mClient. Specify the buffer size, again with the parameter. and for the log file, use the parameter as well. Set the encoding to UTF-8 and then click on Get Field. Finally, click on OK. And basically, our fetch transformation is now finished. We import the raw data, we look up the technical keys and output everything to MoneyDB. So we have achieved quite some work for now. Welcome to the orchestration chapter. Right now, we are in the position where we have most of our transformations finished. The next requirement is to execute these transformations in a specific order. We can use kettle jobs therefore. First, we want to load the dimensions in parallel, and once this is completed successfully, we want to load the fact table. In our case, we only have one fact table, but in theory, you could then load the fact tables in parallel as well. Okay, let's get started. Open up your favorite query client and then from the accompanying files, open up the SLS, Agile and DMA DDL SQL script. Scroll down until you arrive at the heading DMA. Mark the whole section. So just scroll down to the last create table statement. Mark everything and then hit execute. Here we drop all the tables and recreate them again to have a clean start. Let's create a new job now. Open up the general folder and drag and drop a start job entry onto the canvas. This job entry always has to be the starting point of any workflow in a Pentaho data integration job. Now let's save the file, our dedicated project folder. Call it jb_load_dims_in_parallel and click OK. Next, add 3 transformation job entries to the canvas and create hops from the start job entry to the transformation job entries. Double-click on the first transformation job entry and reference the dim customer transformation. It's always good practice to give the job entry a meaningful name, so I usually just use the file name here. Just copy the file name up here for the name of the job entry and click OK. Next, reference the lens transformation file. Again, copy the file name to the name field. And finally, the same for the date dimension transformation. So when you look at the workflow now, you can easily understand what's happening here. Next, we want to make sure that the date transformation is only executed with the very first run of this job. So we add the condition, open the conditions folder and add evaluate rows number in a table to the canvas. Just put it onto the very last hop and then when asked, click yes, double click on this job entry and set the connection to SLS_DMA. The target schema, we can make use of the parameter again. So varDB DMA schema and the target table is dim_date. Next, define the success condition. Set success when rows count equal 2 and the limit is 0. So when the row count equals to 0, meaning when there's nothing in the table, only then we want to execute the dim date transformation. All the other cases, we just don't want to do anything. for that reason, add a dummy step, so just search for dummy, and direct the error flow to the dummy step. The secret to run job entries in parallel is to right-click on the Start job entry and choose Launch Next Entries in Parallel. Read the warning message properly, make sure you understand it. You can see that the hops are now dotted to indicate that all the following job entries are executed in parallel. These transformations here won't finish all at the same time, so if you had any other job entries connected after this transformation, they would start all at different times. So a standard practice is to not add any other job entries after the ones that are executed in parallel. The setup shown here is a good practice, as the parallel execution is encapsulated in a dedicated job. If you have any other job entry to execute after this, you can create a parent job which first calls this job and then whatever task you want to perform after this. You will see an example of this later on. So everything is set up and we can execute the job now. Just to sum up, you learned how to create a dedicated job which executes several transformations in parallel. And as a special condition, we added that the date dimension should only be populated on the very first run. Next, we will create a parent job which runs this job and the transformation to populate the star scheme. Just test this job now to make sure it is working properly. Welcome, ladies and gentlemen, to the second part of the orchestration chapter. Previously, we created a job which loads the dimensions in parallel, so all our transformations mentioned here will be executed in parallel. Now we want to create a main job which executes this job here first and then the transformation which populates our fact table. Okay, let's get going. So create a new job, save it as job load DMA. And then from the left hand side, choose the Start, Job, Transformation and Success job entry and create some hops between them. Next up, double click on each step and we will reference the respective file. So for the first one, it will be job load dims in parallel. And we also want to make a bit more descriptive, so the file name here. For the transformation, we'll choose the fact transformation. Again, copy the file name. And that's basically it. So quite a simple setup. So there's one thing that we have to keep in mind when we run this process for the very first time. Basically, our source database might hold a huge amount of data, like let's say terabytes of data, and obviously we don't want to bring this over all in one go because we might max out our storage, our memory and so forth. So it's way better if we bring over the data in very small or in quite small chunks, and we will be looking at a very simple approach on how to do just this. So for now, I will add where close to the import query and parameterize that one. So just open here the transformation, double click on the input step and add the nice where close. So we say where as date is bigger or equal, and then quotation mark, dollar, opening curly brackets, var fact sale start date, closing curly bracket, quotation mark, and then we say end as date smaller or equal the var fact sale end date. Okay, And then don't forget down here to tick replace variables in script. And then click OK, save this transformation, go back to the main job, so job load DMA, go on job settings, parameters, and we have to define parameters there. So we say we want start and end date. I want to, in this case, import everything from 2013, 101 to, let's say, 2014, 101. And then we can just save it and run it. So basically, what you learned in this chapter is to define the order of executions of all your jobs and transformations that populate your star schema. Next up, we will be having a look at change data capture, so stay tuned. Welcome to the ID-based CDC chapter. As you might know, CDC stands for Change Data Capture. The requirement here is that our ETL process has to pick up any new data automatically. We will base the change data capture on the sale ID because we think this is reliable. We saw that every fact source record has a unique ID, and we can use this one to identify new records. There are other kinds of change data capture methods, but in our case, the ID-based one should work best. Okay, let's get started. Let's have a look what data we have so far in the fact table. So you see we have data up to sale ID 21. Let's now load some new raw data to simulate this in our tutorial. So in the folder that you downloaded from the paved website, you find the file called SLS raw CDC dump. So now just import this to MySQL. So use MySQL. Then we want to import it to SLS raw. And we define our user credentials. So in my case, user root and password root. And we feed in that file, so SLS raw CDC dump. Okay, let's double check this and see what happened. So we see there's a new record here with ID 22. Then we'll import that one then with our CDC approach. Okay, let's create a new transformation and save it as dr CDC set variable. And all we want to do at that point is to retrieve the maximum ID from the fact table. So we define the connection SLS DMA and say select max sale ID as max sale ID from our DMA fact sale table. So let's preview this. So now that would be quite alright, but it's not really bulletproof. In our case, we have already data loaded. There could be a situation where we have no data loaded. Let's say we start right away with the CDC approach. So we want the case statement here. So we say case when this ID is null, then that's 0. Else we want exactly the max sale ID. Okay, so preview that again to make sure it's working. Still getting back our 21, looking good. And then next up we will add our set variable step, which you can find in the job folder, and then we will set this variable for the root job. Okay, just drag and drop this onto the canvas, create the hop, and then click on get fields, and then we want to rename this. We say max fact sale ID, and it should be valid in the root job. Okay, That's looking good. So we just save this one. And then we actually will adjust our fact transformation. So let's open that one. So open fact sale. Save it as a new transformation. So save fact sale CDC. And then we just adjust the input statement. So we say where fact as sale ID is bigger than the value we get back from this earlier transformation. Okay, that's it, and we just save this. So basically, so far you learned what change data capture is. We applied the ID-based method, so we retrieved the maximum ID from our fact table, and we passed it on to our fact transformation. So now there's obviously still the job missing, and we will have a look at it in the next part. Welcome to the second part of the CDC chapter. Previously, we created a transformation to retrieve the maximum sale ID from the fact table. Also, we adjusted the input query so that only data, new sales IDs, is imported. So we have to create a job to take advantage of this. So click on New, then Job. Save the file in our dedicated project folder as jb_fact_sale_cdc and click OK. Add the start job entry, and then we want to run the transformation which sets the variables. So add another transformation job entry and connect it. Double click it and then choose our drcdc setvar transformation and click OK. Remember to always provide meaningful names to our job entries. Just copy the transformation file name up to the name of the job entry. Click OK. It is important to remember that we have to set this variable before we can start using it in other jobs or transformations. The next thing I usually do is to make sure that the data doesn't exist already in the target table. So from the scripting folder, add the SQL job entry and connect it. Double click on it. For the connection, choose SLS_DMA. Tick use variable substitution and then write delete from dma.fact_sale where sale ID larger than. Then we reference the variable we created earlier on, which is max_fact_sale_ID. Click OK. This is basically for your peace of mind to make sure that we do not import data by mistake several times. So we clear the way first by deleting all the entries in the target table that are larger than the given sale ID. Next, we want to run the fact transformation at the transformation job entry, and then can double click on it and reference our fact sale CDC transformation. Just copy the name again to the name of the job entry field. Click OK. Finally, add a success job entry, and then this time, to have it all properly set up, we also want to add a board job entry, and then simply just create hops for all the main job entries here and save it. Now we also have to adjust our main job, so open up JB load DMA. OK. save this job in our dedicated project folder as job load DMA CDC. Click OK. Then delete the transformation job entry and add here another job entry. Connect it, double click on it, and then reference the job we just created, which is job fact sale CDC, and click OK. Here we also want to add the board job entry, so add it to the canvas, create hops from the main job entries. Now you can save the job. And that's all done now. Once you execute this job, we should see our new record in the fact table. So your change data capture is working now. In the next chapter, we will look at scheduling. Welcome to the logging and scheduling chapter. Logging and scheduling are two tasks which we usually implement at the very end of the development process. Okay, switch to Spoon, and the first thing we will do is set up and define some parameters which will allow us to keep the logging settings flexible. So go to Edit and then choose Edit the Kettle Properties file. Scroll down until you find Kettle Job Log Schema and set it to ETL. Then Kettle Job Log Table set to log_jobs. And then there are similar parameters a bit further down for the transformation. So set Kettle Translog Schema to ETL as well, and the Translog Table to log_transformations. Then click OK. So as you can see, by using these parameters, we keep our options open. That's it for now. Next we will then set up the logging for our jobs and transformations. Welcome to the second part of the logging and scheduling chapter. Previously, we defined some logging parameters to keep the setup flexible. Also remember that at the beginning of the course we created a dedicated database schema called ETL to store the logging data. We also set up the SLS_ETL database connection in Spoon, where we use parameters as well for the connection details. Now we will configure our jobs and transformations for logging. With the fact sale CDC transformation open, right-click onto the canvas and choose Transformation Settings. Then click on the Logging tab, and for the logging connection specify SLS_ETL. For the logging schema, press Ctrl-space and look for Kettle Trans Log Schema. So we have to scroll a bit down. And for the logging table, specify Kettle Translog Table. Could also specify the logging interval and the log record timeout, but for now we will leave that. We want to retrieve also basic statistics, so down here for lines written, specify table input, and for lines output, we want to specify the MongoDB bulk loader step. Here on the left-hand side, you can see you have different levels of logging. Right now, the transformation logging is the highest level. You could go a step more detailed onto the step label, then the performance level and the logging channels. For us right now, the transformation level is more than good enough. Next, press the SQL button and Kettle will generate a proper create table statement for us. Can delete the create index statements at the end here because we are MongoDB, we don't need them. Then click the execute button and make sure the statement is executed properly, which is the case here. Click OK and close, then click OK here again. Next, we also want to set up logging for our main job. So open the job load DMA CDC, right click on the canvas and choose job settings, and then click on the log tab. As you can see here on the left hand side, you have 3 different log levels. For us, the highest level is more than sufficient right now. For the log connection, set SLS_ETL. For the log schema, press Ctrl space and choose kettle job log schema. And then for the table, choose kettle job log table. Again, you could define the logging interval and the log line timeout in days. That's it for now. Actually, everything is mostly set up. The only thing left to do is to create the dedicated logging table. So click on the SQL button. And again, kettle creates the create table statement for us. Just click execute and make sure it's executed successfully, which is the case here. Click OK, close, and OK. Now save your job. To sum up, you learned how to set up logging for Pentaho data integration jobs and transformations. We make good use of parameters to keep the configuration flexible. Once you have the jobs and transformations running, the log tables will be populated automatically. Now you can go ahead and configure the remaining transformations and jobs for logging. Welcome, ladies and gentlemen, to the last part of the logging and scheduling chapter. In this part, you guessed it, we're looking at scheduling. So our ETL process is ready, has CDC implemented and whatnot. So the only thing left for us to do is to actually schedule it. So open the file jbload dma cdc.sh from the files that you downloaded from the backed website. This file basically sets a few environment variables and then executes our CDC kettle job. Okay, from line 5 to 7 you see that I set some variables. You won't really probably have to do this, because if you worked along and just used default kettle settings, chances are that you are using the kettle properties file which is stored in the default location under your home directory in the hidden kettle directory. So you can ignore this, but I'll just quickly explain. So I set the project folder. This is where I store all my files. Then this kettle home variable basically points to the directory where I have this hidden kettle folder, which holds as well the kettle properties file. And the last one, the JNDI root, basically points to the directory where the JNDI definitions are stored. We haven't made use of them in this project, but it's quite useful maybe for other projects that you're working on. Okay, so next up, basically, we have to use the kitchen utility. So in my case, basically, I use the trunk version of kettle. So your path will look a little bit different here. But inside the kettle directory, you find the kitchen utility, which we will use to execute our CDC job here. So we reference that file with the full path, and then we set the logging level to basic and output log. In this case, I output it to the temp directory, but that's just because I'm testing. Don't do this in production. Output it to a proper dedicated logging directory. So that's it. Quite short and easy. If you do that on Windows, it won't look the same. And there are some instructions online on the Pentaho info center on how to do it. It's fairly similar, should be quite easy to follow as well. As said, I'm mainly working on Linux, and I guess chances are high that you will do the same. The first thing to do is really we want to make sure that this shell script is working. So we will just execute it. So in the folder that you downloaded from the backed website, you find this shell script. So we will just execute it, and good practice is to open another tab and just use the tail-f command. Follow that error log. So it's in temp, job load, and we see that our ETL finished successfully. So now we can schedule this process. We just type in cron tab -c and go to the very end and insert the new entry. So first we need to decide when we want to run it. So let's say we want to run it 10 past 2 in the morning each day. So we say set it up like this, so minutes, hour, and so forth. And then we specify the full path to the file that we want to execute. So that's our shell script. And then we just save and exit. So you see the new cron tab was set up. And from now on, the ETL process will be executed exactly this time. So for those users that are working on the Windows platform, very briefly, as said before, instead of the shell file, you will use batch file. And to schedule this file, you can use the Windows task scheduler, which is quite easy to use graphical interface. So it should be fairly straightforward to set this up. So that's rounding off the whole introduction to how to create an ETL process to populate a star schema. I really hope you enjoyed it and you learned something new and can set all this into practice. So thanks a lot for attending this, and I hope you really take good learnings from this.